So when we multiply integers, it's super easy to take 2 times 3 and get 6. No problem. Even if we multiply rational numbers, 1/2 times 3/4, that's just the numerator multiplied and the denominator multiplied. And reduce if you can. Also no problem. Even adding variables doesn't really create a huge problem. We've been doing this already for weeks. 2x, if I want to multiply this by, well, what we've been doing is multiplying it by itself to find, to convert a monomial into a radical. But this would just be 4, because 2 times 2 is 4, and x times x is x squared. Easy enough. But what am I going to do if I want to multiply 2x, a monomial, something I already understand, to the number 3x plus 7? Now what do I do? This one's more confusing, right? Because, well, I'm not quite sure what to do with this when I want to multiply by the 2x. Our instincts might say to multiply 2x times 3x to get 6x squared, and then the 7, because it's not a like term, we're just going to leave it alone. And that's a good instinct when you've come through the path you've come through to get here, but it's incorrect. So first, let's just make sure that we're really clear that these are both polynomials, that the first one is a monomial because it's a number with only one part in it. The second one is a binomial because it has two parts. It's one number with two parts or two terms. And none of the terms are alike. If there were like terms, I would combine those before I would do anything. But I don't have any like terms. I have 2x and 3x are like terms, but remember, we've been using like terms when we combine them under addition and subtraction. We haven't done anything yet with like terms in multiplication. So here's what you have to do, and it's kind of simple if you think of it in words. If you have a number with one part, right, one part, and a number with two parts, you need to multiply the one part of the first number twice. You need to multiply it first to the first part of the second number and then to the second part of the second number. And this is called the distributive property. And what it really means is multiplication for polynomials. And you'll use distribution on some other types of numbers, but for the most part, we're going to work with polynomials all this year. So let's go ahead and do this problem I started with before. I've got 2x. And I've got 3x plus 7. And sometimes these numbers can get very big because remember, a polynomial can have many parts. We just have one number with one part and one number with two parts. But what if I wanted to multiply a number with 4 parts to a number with 8 parts? Okay, maybe that's not the language I should use because I pretty much never want to multiply that together. But what if I had to? I need a note-taking or a bookkeeping kind of strategy. So the one I like to use is called rainbow, right? So I'm going to multiply, I put a dot over the number I want to multiply to the other number, and I'm going to multiply the first part, or the only part of 2x, to the first part of the binomial. And that gives me 2 times 3 is 6, and x times x is x squared. Then I'm going to multiply that same number to the second part. So I get, now watch this. I have to end up with addition in between because I have an addition here. I can't just disappear it because I wish it wasn't there. So, but it could be, sometimes it could be subtraction, and I'll show you some examples that do that. So the way to think about it is think about a monomial or a term as having minus, let's go with minus 2x squared. So we have the sign part, we have the numeral part, which we call the coefficient, and we have the variable part. Right? So we have these different parts, but think about the sign as being a part of the actual term. So if I multiply 2x times 7, it's a plus 2 times a plus 7. Well, two positives makes a positive. 2 times 7 is 14, and then x times, well, I don't have an x here, right? So I just have one x left. That part seems a little counterintuitive sometimes, but it's really just multiplying. What comes behind the 7 is a 1. We don't write it because that'd be crazy. Why would we write that every time? But I'm really multiplying the 2 times the 7 and the x times the 1. That really is all there is to distribution. Not that distribution is an easy thing to learn, but with practice you'll get much better at it. And I'm going to do a whole slew of examples and see if we can come up with every possible scenario that might come up. So example 1, I want to multiply 3 into x plus 6. Okay, well this is just a monomial, right? It's just the constant part of a polynomial, so that's a monomial. Well, we don't call it a monomial. It's the constant part of a polynomial. And then x plus 6 is a binomial. It has two parts. So I'm going to have to multiply this first number into two separate parts. So first let's multiply it into 3x, or into the x. So 3 times x is just 3 times x. Just write that down. And then notice that I have a plus sign. Plus times plus is a plus. 3 times 6 is 18, and that's my answer. All right, another example. Let's multiply y times y minus 12. So now there's a minus sign. Let's see what happens when we do that. It's a monomial into a binomial, so I'm going to multiply from the y into the first part of the second number. So y times y is y squared, and then I want to multiply y times negative 12. Well, y is positive. A positive and a negative is a negative. Y times 12 is just 12y. That was pretty simple. Let's do another one. Y minus 2. That's my binomial. And negative 4. Okay, this one looks a little bit different. And the only difference really is that I put the binomial in front and the monomial in the back, but it looks very strange. And I have a couple of choices. I could just rainbow backward and do exactly the same thing I've done up here. Multiplication is commutative, so I could move the negative 2 up front and just switch the order of the numbers. But I'm going to do something else because I want to show how the rainbow works really well for us. Oh, and look, I didn't do my whole rainbow. There we go. So I'm going to show the rainbow. I have a number with two parts that I want to multiply to a number with one part. So I'm going to start with the first part of the first number, and I'm going to multiply it into the first part of the second number. So I get y times minus 4. Well, a positive and a negative is a negative, and y times 4 is just 4y. Now, if I had more parts, I could just keep rainbowing into however many parts I have. Luckily, I only have one, so I'm kind of done there. But I'm not finished with the multiplication because I haven't multiplied that second part of the first number into the second number. So I'm going to take minus 2 and multiply it into negative 4. So a negative and a negative is a positive, and 2 times 4 is 8. So this is just a kind of note-taking, just to keep structure where you are in a problem. But notice that if I had started with the negative 4 and worked backwards, I would have actually gotten exactly the same rainbow. So you can work in either direction, but I encourage you to practice a few different directions because you never know how it's going to come up for you. And you're not always going to have the luxury of being able to switch things around at will. Let's do one more example and then we'll call it a day. Minus 5x times 4 minus x. All right, it's all multiplication. So all those minuses, we can't just arbitrarily combine these because we have addition here in our number. It's a part of our term. So we're only doing multiplication, but remember, when you have a polynomial, you have terms and you have to respect the terms of the polynomial. So I'm going to multiply the first number to the first part of the first number to the first part of the second number. So I have a negative 5 and a positive 4, so it's going to be negative. 5 times 4 is 20, and x times 1 is just x. Then I'm going to multiply the first number into the second part of the second number. A negative and a negative is a positive. 5 times, well, the number that I'm not seeing is a 1. 5 times 1 is 1, and x times x is x squared. And then usually we like to write them with the biggest power first, with the biggest exponent first. So we might switch this to 5x squared minus 20x. It's also prettier if you don't have a negative out front. It's not required. I'm not going to hold you to it, but it is something that we kind of tend to like to do because it just looks better. Okay, I did say only one more example, but I see that there is one thing that I need to show you explicitly. And you've kind of done this a little bit too, but haven't necessarily had it described to you. So if I want to multiply the opposite of 3y minus 9. Okay, what the what? What is that? That makes no sense to me because I don't have anything to multiply, right? Well, I do. Because remember, whenever you have a negative, you really have negative 1. So this little dotted in 1 means it's the number that we don't write very often, but sometimes it's helpful to put it down there so we can see it. So now what I am really doing is multiplying each part of the second number by the number negative 1. So if I multiply negative 1 to 3y, I get a negative and a positive. 1 times 3, and then y. And now I multiply the negative 1 into the negative 9. A negative and a negative makes a positive, and 1 times 9 is 9. Okay, now I'm really done.